the third project, Making CSP Great Again, and Joe is giving the presentation. Please come online. Making CSP Great Again. Hello.
Hello, hello. Can you hear me?
Yes, and I can also see you.
All right.
Please share your presentation.
Okay.
If you have videos with sound, please share also the sounds. How do you pronounce your name?
My name is pronounced João, a very Portuguese name. That's how you know if someone is Portuguese or not, if they can actually say it correctly. They all say it.
Bom dia.
Oh yeah, there you go. All right. Okay, can you see my screen?
Yes, it looks good. Please go ahead.
All right. So hello everyone. My name is João. I'm with Monica, Sonal, and Kate on our Make CSP Great Again project, a zero library project, which I will explain to you why we call it like that. But basically, the idea. So we're working with the stroke rehabilitation dataset, and we have basically two benchmarks of two data analysis pipelines. One of them is CSP plus linear discriminant analysis, and the other one is principal component analysis and the temporal variant linear discriminant analysis. And when we were looking at this, I felt like it's crazy that CSP underperforms so badly PCA plus TV LDA, especially because it's I'm writing up a paper saying that CSP is awesome at this point, and then I look at this and I'm like, wow, maybe there needs to be some improvement. So we set our goal to actually make CSP methods work just as well as these amazing benchmarks as PCA plus TV LDA. So yeah, can we get the same results tweaking the CSP approach? Let's see. So on the original paper, the CSP approach used 4 spatial filters because it was proven before that it was the best. But is this actually optimized? To basically answer this question, I used the grid search cross-validation to try and figure out if 4 was actually the best way to the best number of CSP filters to use. And then another thing that I realized when I was reading the paper on how the paradigm was actually conducted is that when you look at the trial, you have an 8-second trial. So, you would usually think this is like 8 seconds of usable data that I can actually, feed into my model, that it's equally, interesting to use and equally informative. But the thing is, from second 0 to second 2, you have kind of this preparation phase where the subject doesn't even know what to think. Is he going to think, move left hand, move right hand? They don't know. So basically, I just used data from 2 seconds to 8 seconds onwards, because that's when the subject actually knows what he needs to think, what he needs to picture, if it's like, moving a right hand or moving the left hand. So once I did this, then I did almost the same thing as the other authors. I divided the data in trials, bandpass filtered using Butterworth filter between 8 and 30 Hz. But the number of CSP filters based on grid search cross-validation was actually 6. And using an LDA classifier with the signals log variance as the main feature, I was actually basically able to attain very close to the performance that they got with CSP LDA, slightly higher, but not that much higher. But can we do something that actually makes this better? So I thought, in the original paper, people use like 8 to 30 Hz as kind of like a single band. But truth is, we know that there are basically 2 bands included here. So one of them is the mu rhythm alpha, and the other one is beta. So basically, if we're able to use CSP on both the rhythms alpha and beta, that would probably give us a better classification if alpha and beta are giving us distinct information about the type of motor imagery class that we are actually trying to classify. So I extended the CSP approach to something that's similar to a filter bank CSP, but with two filter banks from the alpha and the mu band, and then that was basically how I did my second solution. So in this case, grid search cross-validation dictated that the best number of filters was 10 for mu, 10 for beta, giving us a total number of 20 filters. And the rest was pretty much the same thing. And now we actually, as you see, we basically outperformed the CSP plus LDA performance on, quite something. So we're almost at 90% accuracy with this filter bank CSP idea, right? But we're still not as good as the PCA TV LDA, right? So what can we do to actually, make this work and make this better? We can try and do two things in one. So basically, if we use kind of, instead of just like trying to classify the trials as one, if we use kind of this sliding window where we actually use, epochs within each trial with overlap, we're kind of augmenting the data. So basically, if you check here the two rectangles, imagine that this is kind of a window, and then at each time step, the difference between the beginning of the orange rectangle and the blue rectangle is kind of, the time step window, and the rest is basically overlap. So this time step is basically what in the CNN you would call the stride. And using this, we're able to create the data set that is like up to 13 times bigger if we use 1/4 of a second as this stride. And then to classify the trials, you can basically do like they do on one of the papers, which is basically get the average classification of these epochs, and then if it's more classified as a right-hand imagery, then we say it's right-hand. If not, it's left-hand imagery. And using this, we were finally able to increase the accuracy to something along the lines that what they had with PCA TV LDA, 0.3% bigger, but I don't think it's even relevant. Yeah, this was the solution that I ended up being happy with. Also, in terms of a reflection, it's important to kind of try to figure out what we tried and what didn't work. We tried a bunch of stuff, even stuff that is not here. The thing that I wanted to mention that I was really unhappy that it didn't work was instead of doing like this kind of oscillatory analysis, I tried to do an ERP analysis post stimulus of the presentation. So once the subject actually knows that they have to move the right or the left hand, I was actually hoping that the ERP elicited by either seeing left hand or right hand information would actually already elicit some information that would help us on the classification. It kind of seems that way if you plot the means across channels, but it was not robust enough for classification. And other bands like delta, theta, or gamma were completely useless, at least in my approach, in making this better. So the reason, closing up, why we call it the Zero Library Challenge is because this was basically written all in MATLAB without any usage of any libraries. So once this is fun, you can control the data, you can see how things are happening, under everything. So I'm putting this on GitHub, so for people who want to learn a little bit more of the maths that's going on behind this. That's it.
Thank you very much for the nice presentation. Also in the chat, you can see people liked it a lot.